Welcome back, this is LLM Zoomcamp, and in this video we are going to replace the toy search engine we used previously with Elasticsearch. Quick recap of what we have done so far. We have a knowledge base which we indexed with a small library search engine, and now with the user query we can retrieve the relevant document, build the prompt, and send this prompt to an LLM, and the LLM will give us an answer. And we already have the code for that, so this is what we implemented previously. And now, and one of these things, like search, uses a toy search engine that we implemented in a pre-course workshop. Now we want to replace it with a proper search system with Elasticsearch. But why did we actually use this toy search engine in the first place, you may wonder. And it's because later in the course we might use tools like Saturn Cloud, where it's not easy to run Elasticsearch, so having something that runs in memory and gives good results is a good thing. Plus, we wanted to see how to implement a search engine, so this is why we used it previously, but now let's replace it with something real life, something you will actually probably use in practice. Okay, so this is the thing. We want to replace the search with something else, so let's do that. First of all, we want to run Elasticsearch. Right now, I'm in my code spaces, and I have this command for running Elasticsearch in Docker. So this is running Elasticsearch of this version. I don't know if it's the most recent or not. Now I'll open a new terminal, and I will execute this command. So I just copy it here. So Elasticsearch will run on these two ports, and now it will download the Docker image and start Elasticsearch. And okay, I don't know. Yeah, whatever. We just need to check that our ports, the ports that we need, are forwarded, and these are the two ports that we actually care about. So we will use this port 9200. So I'll create another terminal and execute a simple HTTP GET request to localhost. This. So this is the URL. I don't know why it cut it. It's localhost 9200. This is where Elasticsearch is running, and we see a response, which means that it works. And actually, we don't really care about this port being forwarded to our local machine, to our host machine, because we are going to use Elasticsearch only within code spaces. But anyways, it forwards it, okay. And now we can see that it works. So now let us first we will index these documents that we have here. Let me remind you, these are the documents we have. So now we want to index them with Elasticsearch and later use this for searching. The thing about Elasticsearch is that it's actually persistent, meaning that unlike this toy search engine, when our machine stops, when we finish this Jupyter Notebook process, we need to basically, next time we start, we need to rebuild the whole index. But when it comes to Elasticsearch, it saves all the data on disk. Next time we start Elasticsearch, it will have all the data we need. So we'll not need to execute it. Of course, it depends on how exactly we run it. So we might need to do volume mapping for that. This is outside of the scope for this course. If you want to learn Docker in more detail, you can check our data engineering course, module 1, where we talk about Docker in a lot of detail. Right now, let us see how we can use it from our Jupyter. So we want to replace this line here. So let's do that. First, I'll import Elasticsearch. So we should have installed it. So from Elasticsearch, import Elasticsearch. I hope I typed it correctly. Elasticsearch, yeah. So I did from the second attempt. So now let's create Elasticsearch client, which can be Elasticsearch, and then the URL, which in our case, HTTP localhost 9200. If you deploy Elasticsearch somewhere in the cloud, then you can just use the URL you get. But yeah, this is the local deployment, and we can check that things work by executing this info function. So this is the same response as we saw before in the terminal. Okay, so it works. We can connect from our Jupyter to Elasticsearch that we run on Docker. And now we need to create an index. So an index in Elasticsearch is like a table in a relational database, and it's very similar to what we have created previously with MinSearch. And usually the syntax for that is rather complicated, so I already prepared this query here. So this is our index settings. And here the interesting thing is this, the properties. So course is keyword, we will do filtering, and the rest are the type of the type text. So this is very similar to what we have done with MinSearch, right? So these first three were text and course was keyword. And now we need to, so these are the settings. So now we need to give the name of the index. So let's call it course questions. And the last thing is we will need to use Elasticsearch client to create an index. So we need to do something like indices create, and then index will be index name, and the settings will be this index settings. So we execute that, and yeah, from what we saw, it went well. The index was created, and we can now index the data with this index. Right? And the way it works is we again use Elasticsearch client. Then we have the index function, and then we need to specify the index name, which will be our course questions, and then the document that we want to index. So the documents that we want to index, they look like that, right? So we basically need now to iterate over all the documents we have, and for each of the document, index it with Elasticsearch. We have rather small data sets, so this should be very fast for document and documents. That's all we need to do to index our dataset. And I also like to add progress bar to that, so this operation might take some time. So we want to see what is the progress, and that's why we installed this tqdm library. So the way I usually import it is tqdm.auto import tqdm. Yeah. Well, apparently I have not installed some library, but whatever, we will still have a progress bar. Yeah, it's not just a fancy progress bar. If I installed Python IPy widgets, it would look nicer, but we can still see the progress that we index at the speed of roughly 30 documents per second, which is very good. So yeah, the indexing is almost over. And now we can query this data. And again, the query I had to prepare it in advance because it's rather complicated to type. I'll explain what's happening here. Let's call it search query. And do we already have a query defined? Query. Yeah, how do we run Kafka? Well, let's use the same example as we did previously. Is how I just discovered the course. Can I still join it? Right, so this will be our query, and this syntax is rather complicated. And then let's look at what we have here. So there are two components. The first component is the filtering component. So this is where it's very similar. It's actually the same as we did before. So it's very similar. It's analogous to this select query where the course is data engineering Zoomcamp. So this is what the filter is doing. So we limit ourselves only to the questions from the data engineering Zoomcamp course. And then this part is when we do perform text matching. And here, notice this hat. So we say with this hat 3, power 3, means that question is 3 times more important than text or section field. Right? So essentially what we're doing here is we're giving more importance to the question field, we're giving it a boost. This is exactly the same thing as we did before in our min search. And the size is 5. So we will get only five answers in the result. Okay, so this is what we do. So this is the query. This is the search query we send to Elasticsearch. And the way we use it is we invoke the client using the search method. And we need to specify the index name. And we need to specify the query. Search query. Right. And we get the results. So let me now write into the response variable. And response would be, so we need to actually somehow get the relevant part here. So it is hidden under like a lot of, like it's quite nested. So I think first we need to go to hits. And then inside hits, we need to have hits again. And yeah, so this is our documents. And I can see that for each hit, we actually have to go inside and get to the source, right? So actually, we need to have a loop for hit in hits. So let me result docs. We'll have a variable here, append hit source. Now result docs contains the documents. Yeah, I think this is exactly the same as we had before. Well, I'm not sure about, I think we are asking about Kafka, right? Let me just re-execute it one more time. So the questions are different, the answers are different. So yeah, this is the answers we get from Elasticsearch. And yeah, like we don't actually need to do much now. So now let's just put this in, I'll put it in a function. I'll call it search, maybe Elasticsearch, right? And then we have a one parameter query. And then we just put everything in this function, right? And then we just return the result documents at the end. So let's quickly test it. Elasticsearch. I'll test it here. This query. So we get some results. And now let's quickly adjust our rack function. So I'll just replace I'll just replace search with Elasticsearch. And now when I execute rack, we should go through the same rack flow and then get the answer. Okay, so this is how we replace one component here, like we replace our toy search engine with a proper search engine. And you can see that this is highly modular, so we can easily swap like all the components. And later in the course, we will also show you how to replace this LLM, the OpenAI one that we used, with an open source one. Okay, that's it for this video. And I don't know if for this week we will have a video where we show how to run it locally. Most likely we will save it for the next week. So have fun and see you around.